Hi everyone. This is the fourth video in the series for autonomous vehicles. Today, I would like to just go through and model a signalized intersection with AVs and just go through basically the steps and just discuss what to do and what not and things like that. So what I have here, this is just a very basic network. All the four arms are identical. I use the only things I've set up are the static routings and the node in the middle and the traffic signal. The traffic signal is just basically has a split phase for each approach with the same time. And what I would like to do is I assign a different vehicle type for each arm, so that will be like a normal human driver, that will be a normal AV, that will be a aggressive AV, and that will be a mixture, human driver and aggressive maybe. Or we can use actually cautious as well and not normal, so the difference will be more significant. What we do is first we set up the driving behaviors, then we need to set up the vehicle types, vehicle compositions, assign the traffic, and we check the node evaluation, how it goes. And we put a little chart probably to just show what's going on, to visualize the outputs. Let's start with the behavior. So what you can see is I have created this urban AV. We will recreate it. I show you what changes have been made. The reason I'm not using these is the aggressive, or these basically use Wiedemann 99. I mean, we can use them, but let's discuss Wiedemann 74. This is more suitable for urban traffic, but I'm not sure you will be far off if we use the Wiedemann 99. Let's use the cautious from this one, and for urban, let's do the aggressive here, a very aggressive AV. Okay? So let me just duplicate this normal one. Urban AV new. So let's just do some stuff. By the way, so I got the settings for Wiedemann, for Wiedemann 74. The settings come from an example from Vizim, a PTV example. It is important to note that these settings are not something you need to stick to. So these have no basic or no base of the settings. There is no research behind it or anything. So it just basically shows what changes you should be looking at with priority when you want to set up an AV driving behavior. The most important, so it's already the number of interaction objects and vehicles are already good. So these fit for the AV. We select the video on 74 instead of the 99. So if you remember, we changed it here. That was one of the key settings. So we had a different gap time previously in the previous video, but let's do this. So the model parameters, basically these three parameters will tell you the following distance and the following behavior, how they will behave. So what we want to do first is we use this to 1. This is the standstill distance. And the additive and multiplicative part of the stacy distance. So basically these will tell the, shall I call it, function, where when the vehicle speed changes, then the following distance basically changes depending on these settings. So let's put it to 1.5, and let's put this one to 0. What you achieve with this is a very close following, so the following distance will be very short. Here we can tick this off, the zipper merging. You can read what it actually does. It's not going to have a huge difference here because we don't really have merging, because we just load vehicles in through this link, that one, and the 2-lane, we just change lane someone who wants to do a left turn, and there is no need for merging, but they switched it off for that setting, so I just thought I'd mention it in case you have an urban setting where you have merging, so probably it's better to keep it off. But again, if your algorithm, the way your cooperation and your AV behave, your assumption says that it needs to be turned on, go ahead and use it. Here we need to increase the minimum longitudinal speed. What it will do is it basically tells they will change lane faster. Okay, signal control. So in many countries, this should be stopped, same as red. This has nothing to do with AVs, but this should be set to stop. In the UK, for example, that is a requirement to use stop, same as red. So it should be set actually for all. But since I keep it go because all the others, and that one, the urban motorized, the default one is go, same as green, so I keep it. But since we are talking about driving behavior, I thought I mentioned that probably it's better to keep it on or put it to stop. Autonomous driving, so we don't want to use implicit stochastics, but we want to use platooning. I want to use platooning, so let's just assume that they can talk to each other and get into platoons. Then the impact will be greater, I think, in the network. Driver errors, so here you want to keep them as close to 0, or probably 0, because autonomous vehicles assume not to make mistakes. Meso is not applicable for our case now. So let's just do this. Let's go setting up the link behavior. Let's do that one. What link behavior does is you can basically assign for the link what kind of driving behavior it to use. So vehicles on that link, what driving behavior they will use, and you can assign it to vehicle class separately. There is a default setting, so let me just set one up. New, very descriptive. So there is a driving behavior default, so we can set up the urban AV new or just the urban motorized. Let's just set by default the urban motorized, and let me just set that new for every single link. So I just select all link, put it to new. So regardless of the vehicle class, everyone will use the urban motorized driving behavior. We don't want that. We want AVs to use their AV driving behavior. So what I do, in the right side, you can add and you can define, you can specify for each vehicle class what they should use. Let's just define everything here to be having a bit overkill. So normal cars should use urban motorized. Car AVs, I will set a car aggressive. There is no car aggressive. So let me just do that. I can also read, additionally, I can read in from the base those settings and then so I don't need to recreate it now. So but I recreate it now. But if you can to read in those settings, you can just do that. So you just go select the network I set out, I think in the first video. There is a path which is into public documents, and then just use that. So I just add, and that will be the driving behavior will be AV aggressive, and there is an urban new. So we use AV new for the aggressive one, and we use cautious. I just create one. Okay, so let's just go to the vehicle classes first. Let's just have a look there. So what do we have? We have an AV aggressive new, and we already have the cautious, so let's use that. So we come back here, so aggressive new, and here vehicle class cautious. Okay, that makes sense. Let's go to vehicle composition. So this will be the default. I rename it to car. I removed the AGVs. There's quite a lot going on here. Let's just select a car, 50 km/h. You can keep the relative flow whatever it is, because there is only one here, so it doesn't matter. Car, this is human. That will be an AV aggressive. That will be an AV mixed, and an AV cautious. I don't know, is it? Yeah, like that. Or whatever. The way you type it. So, okay, let's keep it like that. So aggressive will be car AV aggressive. Mixed will be let's do aggressive and human driver 50-50. So the normal car is 50 km/h. This is 50.2. So you can see there is a desired speed distribution ordered. So I have imported that before. So you need to make sure you select the correct one. Or if you don't want to import, you just set up your own basically, again, according to your assumption. So by default it is 2 km/h plus minus. And AV cautious, like that, like that. Let's just do a double check. Yeah. Okay, everyone has a 50 speed. Let's create the vehicle inputs. Just show the list. So they are all here. Let me just select southwest. Will be car human, then south will be car aggressive, mixed, cautious. Let's put it, I don't know, 750. We can change it if the model, if it's not high enough or something, or if it's too high. All right, let's set up the node, or make sure it is set up. So node, let's stick it on, and interval is 1 hour, time to 1 hour. We don't need to change anything here. We want to select all, or we can just select the one we want, but we just need to double check that in the car vehicle type, AVs are not included. Okay, AVs are not included. All right. I think that's good to go. Let's have a let's have a quick check on it. Okay, vehicles are coming. Because my computer is quite slow. Let me check its maximum. Super fast. What we can do, let's just have a look. Let me just have a look quickly. This is fine. Equal type 1. Let's just double check that our inputs vehicle compositions are fine. Vehicle composition 100, 190, 190, 170. Okay, vehicle classes. Okay, so AV aggressive node, that is incorrect. I should have set it up. So that is car aggressive only. That's fine. Let's car cautious. That's 170. That's the right one. Car, that is correct. Okay. Let's have a run. Hang on, something is okay. So let's set up a chart. And let's show the Q length and the delay. Create chart. Here I select movement because I want to show it by movement. I highlight network objects. Here I click plus. These are my movements for node 1. These are the ones. Let's pick the west east, north south, south north, and east west. So the 4 main ones. We need to set up the X labels, but I can't remember which one is which, so we need to check it. So attributes, what attributes we want? We want average Q length, current run, current interval is fine. Vehicle delay, over types. Yeah, like that. Only thing we need to check is which link is which. So let me check. The south is, this is 7, south is 7, north is 3. So this is south, north, 1 is on the west, 1 is on the west, so this has to be the east one. Okay, so what we see, let's just run it for a bit, because the results only show represent like 10 minutes, so let's run it. Okay, we're around half an hour now. So north, what do we input in the north? It is the cautious. So as we discussed before, for cautious, they use a brick wall distance. So what that means is they maintain a very, very, very big gap. And they maintain that large gap because they need to stop, or they want to stop assuming that the leader vehicle, the one downstream can instantly change to a brick wall. So if I show you in force, absolute braking distance is ticked on, that's what goes in it. Yeah, so that's why it is absolutely massive there. West is car human, so as you can see the car human is the second worst. East, which one is east? Mixed. And the best is the aggressive, which is this one. So what it shows is that with these unfortunately probably the traffic volume is a bit too high and they can't get into to the lane. So let me just reuse a bit. Okay, let's have a look at the warnings, just do some trouble. So all these warnings don't mean anything bad, so it just basically says that it's not assigned to any vehicle class. We just had a few multiplication due to the read additionally, which I did earlier before the video. But we don't want to assign this to anyone. This is just for waiting, so what it does is it was removed because it was waiting there for 60 seconds. Again, you can change these in the driving behavior. Here, waiting time before diffusion 60. If you increase that, then the removal will happen much later. What this means is just basically the input, there are vehicles waiting outside, so there is a virtual queue or a latent demand. So let me just list these and put it to 600. Like a trick, you can select these and just type and it will update all of them. Let's rerun it. Let's run it a bit more so we can see some proper averaging. Again, it is very interesting. So you can see that the aggressives can always clear the queue. Humans and the mixed, there is always a bit remaining. And for the cautious, due to the high or the large gaps, is the worst. So there is still a lot to this autonomous vehicle thing. I am happy to explore, but I need your input. Please talk in the comment section and let me know what kind of content you want in this AV field. We can do some more tests or some specialized stuff we can discuss. Just let me know what you are interested in. If you like what you saw, please like and subscribe. It would help the channel to grow. And thanks a lot for watching. And see you the next time.